Hi friends, this is K.UDAY Kiran. In this video, I am going to explain about binary search in C program. At first, I am going to give you a brief information about binary search and explain it to you how does it works, and with an example, I am going to make it clear for you. Binary search has many names such as half interval search, logarithmic search, or binary job. There are two main types of search engines. Those are binary search and linear search. In these two, binary search is faster than linear search, but for small arrays, linear search is more faster than binary search. But for there's a small problem in binary search and an advantage, because in binary search we have to sort the given list first for searching process, and we can also solve many problems. It has a wide range of scope for solving problems, such as finding the next smallest or next largest element in the array relative to the target, even if it is absent from the array. The idea of binary search is to use the information that the array is sorted and reduce the time complexity to of log n. This is why it is fastest, because we reduce the time complexity to make it faster. Now I'm going to explain to you how it works. At first, binary search compares the target value to the middle element of the array. If they are not equal, the half in the which the target cannot lie is eliminated, and the search continues on the remaining half, again taking the middle element to compare to the target value and repeating this until the target value is found. If the search ends with the remaining half being empty, the target is not in the array. Now let's proceed to algorithm. The algorithm for binary search is very simple if you understand. Binary search works only on sorted arrays. That means, for example, for numericals, it should be in ascending order or descending order for binary search to apply. Binary search begins by comparing an element in the middle of the array with the target value. If we want the value, for example, if we want a value of 5 from 1 to 10, first it searches 5 in the middle of 1 to 10 values, middle position. If the target value matches the element, its position in the array is returned. If the targeted value is less than the element, the search continues in the lower half of the array. For example, in 1 to 10 numbers, if we want 7, in the middle value is 5. If we want 7, so it's the value we need 7 is greater than 5, so it eliminates the lower members of 5. Like this it continues, the search continues in the upper half of the array. By doing this, the algorithm eliminates the half in which the target value cannot lie in each iteration. This is simple to understand with an example. I will explain it to you with an example later. Now let's look into the procedure. If we are given an array of n elements with values or records a0, a1, a2 and so on, like an minus 1, sorted such that a0 less than or equal to a1, less than or equal to a2, less than or equal to so on, less than or a n minus 1. As I explained it to you before, for binary search it should be in ascending order or descending order. It should be in sorted ways. Okay, and let us name as target value t, our target value as t. The following subroutine uses binary search to find index of t in A. Means we are doing this binary search to find t in the arrays of A, array of elements. Now first we set L to 0 and R to n minus 1, and then if L is greater than R, the search terminates as unsuccessful. Set M, the position of the middle element, to the floor of L plus R by 2, which is the greatest integer less than or equal to L plus R by 2. Means if we get 4.5 or 3.5, we'll consider as 3 or 4. If am is less than t, set L to m plus 1 and go to step 1. If am is greater than t, set r to m minus 1 and go to step 2. Now am equals to t, the search is done, return m. If in an elements 1 to 10, if our required number is 7, it is greater than 7. The 7 is greater than the middle value, so we use m plus 1. If the required value, that means if the targeted value is 2 or 3, which are less than the middle value, then we take m minus 1. If middle value is the same, is the targeted value, then the search is done and the process is completed. Okay, this iterative procedure keeps track of the search boundaries with the two variables L and R. The procedure may be expressed in pseudocode as follows, where the variable names and types remains the same as above. Floor is a floor function, and unsuccessful refers to the specific value that conveys the failure of the search. This is a pseudocode that should be used for binary search. With this pseudocode, you will be able to use binary search effectively. Next, alternatively, the algorithm may take the ceiling of L plus R by 2. This may change the result if the target value appears more than once in the array. Now this is the example. Okay, this is now we are given with some values 21, 4, 9, 5, 2, 15, 12, 7. I picked it random, and let us consider that we need 12. First, for a binary search, it is mandatory for it to be in an order. So I arranged it in an ascending order. So we have now 8 numbers, but as we give first position as 0th position, first position for the 0th position, the positions are marked. The positions are marked. Now we determine the middle value. We use the formula middle equals to low plus high plus low by 2. Means you can observe that low means here the lowest position, and high means highest position. The highest position is 7, we can see that, and the lowest position is 0. Now by giving the values, we will get 3.5. As I said earlier, if we have our values 3.5 or 4.5, we will consider as 3 or 4. Now as we got 3, now we compare our third position number with our required number. We have 7 in the third position, so the targeted number is 12, which is greater than 7. So we eliminate the values less than 7, and as the 7 itself is not 12, means they are not equal, we eliminate it also. So now 2, 4, 5, 7 are eliminated, and values above 7 are still in the game. As it is greater, these greater values are there, 9, 12, 15 and 21. Now again the process is repeated. Now we give mid value as low plus as same mid plus 1. We change our mid value, we change our low value as mid plus 1. Low equals to mid plus 1. As previously, mid equals to 3, right? Now 3 plus 1. We replace low equals to 3 plus 1, that's 4. Now we get, by replacing the values, we get our new mid as 5. As we got our new mid as 5, now we compare the values. In the fifth position, there's 12, our targeted value. As we found our targeted value, the search terminates. So it concludes that our targeted value is in the fifth position. I hope you understood binary search with this example. Now let's move on to different variations of binary search. There are so many different types of binary search. Uniform binary search, exponential search, interpolation search, fractional cascading. Uniform binary search. Uniform binary search stores instead of the lower and upper bounds the difference in the index of the middle element from the current iteration to the next iteration. Exponential search. Exponential search extends binary search to unbounded lists. It starts by finding the first element with an index that is both a power of 2 and greater than the target value. Afterwards, it sets that index as the upper bound and switches to binary search. Interpolation search. Instead of circulating the midpoint, interpolation search estimates the position of the target value, taking into the account the lowest and highest elements in the array as well as the length of the array. It works on the basis that the midpoint is not the best guess in many cases. Fractional cascading. Fractional cascading is a technique that speeds up binary searches for the same element in multiple sorted arrays.